Okay, in this video we're going to discuss an introduction to functions. We're going to start by defining what a relation is. We say that a relation is a set of ordered pairs. So if I were to list an set of ordered pairs, 3, 4, 5, 7, 6, 9, negative 2, 5, this would be an example of a relation. Now within a relation we can identify the domain and the range. We say the domain is the set of all inputs, which in this case that would be the x values 3, 5, 6, and negative 2. Notice I've listed those here in order from smallest to greatest. The second set of numbers is called the range. That's the set of y values. That's 4, 7, 9, and 5. So again, I've listed those again, 4, 5, 7, and 9 in order from smallest to greatest. Now that we know what a relation is, we can now kind of talk about what a function is. By definition, we say that a function f from a set A to a set B is a relation that assigns to each element x in the set A exactly one element y in the set B. Again, just to kind of take a look at a real-life example of that, let's say that, for instance, we have a simple interest I earned on $1,000 for 1 year is related to the annual interest rate by the formula I equals 1000 R. So, for example, if R is my input and I say that R is 1, my interest is going to be $1,000. If I say that my R is 2, then my interest is going to be $2,000. This is an example where each input is going to have exactly one output, so therefore this would be a function. Let's take a look at a table example here. Now this table represents a function also, the time of day as compared to the temperature in degrees Celsius. So notice for each element in the domain, it's paired up to an element in the range. Now the characteristics of a function, there are 4 basic characteristics. Number 1, each element in set A has to be matched with an element of B. So notice here at 3 o'clock it's 15 degrees Celsius. Well, at 4 o'clock it's also 15 degrees Celsius. That is okay for it to be matched up to the same element in the range. Number 2, some elements in the B or in the range may not be matched with any element. So notice here we've got a number of temperatures that we have that are not actually being used. That's okay for it to be a function. Number 2, 2 or more elements in A may be matched with the same element in B. That's kind of what I mentioned earlier. So at 3 o'clock and at 4 o'clock, it was 15 degrees Celsius. And then the last one, and this is probably the most important one, is an element in A cannot be matched with 2 different elements in B. In other words, at 2 o'clock, it can't be 13 degrees Celsius and 9 degrees Celsius. So that would, again, those are the 4 main characteristics of a function, just using the chart there. Now let's talk about ways we can represent a function. The first way would be just simply verbally. We can describe it with a sentence, how the input variable is related to the output variable. Example of that, the input value of x is the number of representatives from a state, and the output value is the y, or the number of senators. Well, in this case, the number of senators, no matter how many representatives we have, is always going to be 2. So technically this is an example of a constant function. Second way would be numerically. That's by a table or a list of ordered pairs. Here we have a mapping. Notice that each element in the domain pairs up with each element in the range. So in this case, this would be considered a function. We have a table. Notice in this one, the table, our input values 2, 2, 3, 4, and 5. Notice that we have 2 2's in the input, so therefore this would not be a function. Okay, and our third way would be graphically. That means that we put points on the coordinate plane and represent the horizontal positioning by the input and the vertical positioning by the output values. Here we have 3 different examples just to kind of give you a scenario here. The first one, we've got a curve that goes up and then goes down, then goes back up. Notice for each x value, we do have exactly one y value, so this would pass the vertical line test, which we're going to talk more about in the next section. So that would be a function. The second one's a linear line. It's also a function. The only way that a linear line would not be a function is if it were a vertical line. And then the last one is a circle. Notice on the circle, for my x value 0, I have a y value of 3 and -3. So therefore, that indicates that this is not a function. It would also not pass the vertical line test. Okay, the fourth and final way is algebraically. We say algebraically by an equation in two variables. So in the first example, we're just going to determine is y a function of x. Well, what we're going to look for here is if I plug in a value for x, am I going to get multiple values for y? So in this one, notice I can plug in 1 for x, I'm going to get 2 for y. Plug in -1 for x, I'm going to get the same value for y. And that's okay, just as long as the y does not, just as long as x, each value has exactly one value for the y. So this would be a function. Let's look at one that's not. X squared plus y squared equals 4. Well, on this one, again, if we would plug in any value for x, we're going to get, because there's a y squared there, we're going to get multiple values for y for an individual x value. So therefore, this one would not be a function.